Um. Hmm.
You may not know it.
I don't know how to do this one.
So it comes from previous ones, although it looks different. Let's see. It's a long way back. Do you remember how these ones work?
Yes.
So what's A?
Would it be 140?
Yeah. And let me just copy that. And so that's 140. And so the angle at the center is twice the angle at the circumference. And so which angle is at the center? Which angle is at the circumference?
In the center is J.
So J is at the center.
Yeah. And then the circumference is 23.
And the angle at circumference is the other one, 23. And so what is the angle at center? And the angle at the center is twice the angle at the circumference, double the angle at circumference.
So it's 46 degrees.
Yeah. So J equals 46 degrees. And all right, we'll leave that. A cyclic quadrilateral is a quadrilateral and all four corners are on the circumference of a circle. Let's see, but does it say anything about it? It doesn't. Okay, let's try this.
Okay, so there is a center. Angle A would be 50.
Let's see. So angle A is 50, yeah.
So this angle B 260.
So B is 260. How about C?
C. So is C 130?
Yeah, C is 130. Okay, let's try question B.
Okay. So 100. B is 150.
Yeah.
And C is 80.
Mm-hmm.
And A is 100.
Yeah. What do you know about what A and C add up to in both questions?
180.
Yeah. And so what that shows you is, well, that's an example of opposite angles in a cyclic quadrilateral add up to 180. So opposite angles in a quadrilateral where all four corners are on a circle add up to 180. Let's see this one in terms of x, in terms of y. Oh, that's tricky. Oh, I think that's just proving it, is it? Okay, let's try this.
Okay. We got the size for each angle marked with a letter. So the other side of A is 95 degrees.
Say it again. Yeah, other side of A is 95.
So these adds up to 180.
Mm-hmm.
So that means, so and the straight line has to add up to 180. So 95 take away 180. 180 take away 95. 85. So A is 85 degrees.
Yeah. Any idea how you get B?
Would you have to? So it's a square and square them.
Opposite angles in a cyclic quadrilateral. Do you know what they add up to?
180.
Yep.
So does that mean B is 95?
Well done. And so that's 95, same as the exterior one. Okay, how about these over here?
Okay. So what looks like the opposite door angle next to E is 82 degrees. 82.
So what one is 82?
The one next to E.
Yeah, alright.
And so that means that E is 98
So
degrees.
E is 98.
And that means that C is 105 degrees.
C is 105.
So does that mean D is 75
Yep.
and F is 82?
And F is 82. Great. And what is this one? Proving this? Okay. Let me see this one. Alright, let's do A, B, and C.
A, B, and C. So 87 degrees. So C is 90.
C is 90.
93 degrees.
Mm-hmm.
And A is 72 degrees.
Mm-hmm.
And B is 108 degrees.
Yeah. Well done. This is more proving. Maybe we could. Alright. More proving. Maybe we could. Alright, let's give this a go.
Okay. That'll eat angle marked X. Angle is DAQ is BAD. Is a tangent to the circle. So that means the circle adds up to 180.
Yeah, straight lines are always 180.
Okay. So I need to find out what X is. Okay.
And you have 85 up the top.
So 85 is the other one is 95, the one at the bottom. And 29 at 95 is 100. So 95 at 29 is 134. And 134 minus 180 is 46.
124, I think, is it? Is it 124? So you put 5 more. Yeah, I think it's 124. So what's that going to be?
So that would be 124 is 56.
Well, no, 56. Yep. Okay, let's try this.
Find out angle mod X. So B is 116. So O is 706. So O is 232.
232. Okay.
So does that mean X is 128 degrees?
So X is 128 degrees, and then maybe I need to move this back. 128. Yeah, okay, so this one. Yeah, let's try question 2, part A.
Question 2. Okay. I got marked with a letter. So B is 50 degrees.
Yep. So C. So they're subtended on the same arc. So it's like the B shape just moved over a bit.
So does that mean they're all 50?
Yep, they're all the same. And so if you see that shape, you know that those are the same. Those angles are equal. Angles subtended at the circumference by the same arc are equal. Okay, let's try these.
Okay. Work out the size of each angle marked with a letter. So A will be 42 degrees.
A is 42. And how do you get B? And this is a diameter. Anything you know about that?
It's double.
So this here is 180. And so what do you know about the angle in the corner?
It is double.
That angle is 360. So the angle at the center is 180.
Yeah.
So what about the angle at the circumference? This will be half. So this one is 90.
Okay, so 90 degrees.
And so how do we get B?
After
So A and 90 and B are in a triangle.
yes. So 42 plus 90. 42 plus 90, that's 132 degrees.
So B.
So B is is it 42 degrees? I mean 48 degrees.
48, yeah. So, well, yeah. 180 minus that equals B equals 48 degrees. Okay, question B.
Okay, so is C 56 degrees? So the line that O is on is 180.
Yep.
So so D would be so D is the angle. So I know that one is 56 degrees and O is 180. So does that mean D is 180?
So this O over here was 180. And so how did we use that?
You found out what was it?
Right.
You found out that the other angle was 90 degrees.
Can we do something similar?
Yes.
Okay.
So is the angle next to O 90 degrees?
The opposite one, that's 90.
Yeah.
Okay.
So then 56 plus 90. which is 146.
Okay.
And then 146 minus 100, which is 34
Well then,
degrees.
that's it. Okay. E and F.
Okay. So 110 degrees. Are they both half of O?
Yep.
And O is 250.
Oh, they're both half of the other side of O.
Oh. So 110 divided by 2 is 55.
That's it. And question D.
So size of the 170 is 190.
Yep.
190. Half of 190 is 95.
That's it. And so G and H are 95 degrees. That's great. Okay, let's see. Alright, let's try question B.
E.
Question B? Yeah, you could do E if you want.
So work out so that we can call O is the center of the side. Okay. So 41 degrees and 32 degrees. So 41 add 32 is 73. 180. 180 from 73 is 107, so F is 107 degrees. So how do I find out G now?
G is vertically opposite F.
So is G 253 degrees?
No. Vertically opposite angles are equal.
Oh. So G is 107 degrees.
G is 107 as well. Okay.
So then, are they just all the same?
So what do you mean? What would be D?
Would D be 41?
Yep. D is 41. And E?
32 degrees.
That's it. Okay, question C.
Question C. 137 degrees. Opposites. So H. So 137 degrees. Does that mean that is I so is I 43 degrees?
I 43. Okay. What else?
So, is H also 53 degrees?
Yeah. And how do you get J?
Take away 43 from 180.
Yeah.
And that is 127.
That's it. Let's see. Right, D. Let me do this. Let's leave D. There's a lot going on in there. Let's see this one. That one seems alright. Okay, let's try this one.
So 25 degrees. Is E also 100 degrees?
E is also 100, yeah.
GAs. Work out size of angle GAC. So I'll go down for a second now. Do I have to figure out what A is?
Yeah, that's what we're trying to find.
Okay. Well, that's a right angle, is it?
What's our angle?
That's, yeah, no, it isn't a right angle. So, the other side, A is 100, O is 180.
What's 180?
The center, because it's on the line.
Okay.
So, that means that B is 90.
So this angle down here is 90, yeah.
So that's 180. So you need to find the other side of A.
Mm-hmm.
Wait, does when you combine the two sides of A, does it add up to 90 degrees?
That would be if dB was a diameter, but it isn't.
Hmm.
Any idea about this angle here?
Is it 100?
No, it's on a straight line with 100.
30?
Yeah. So that's 80. Any idea about this angle up here?
So see, would that be?
So it's in a triangle.
20? Is it 25?
No.
Oh no, 90. Oh. Do you have to do 90 plus 25?
Yep.
Which is 115.
Okay.
And you have to do 115 degrees minus 180.
Right.
And that is 65 degrees.
Okay. And so that up there is 65. How can we use that? Any ideas? So it's similar to these ones back here. What did you know about D and 41?
They're the same.
Yeah. And so this is the same idea.
Oh, so that is the same as A?
What is the same as A?
Is C.
The
other side of A.
No, these two up the top are the same as each other. They're both on the same arc.
Oh. So that's 65 degrees.
Yeah.
So you have to do 65 at 80.
Yep.
145. 145. 180 minus 145 is 35 degrees. So the other side is 35 degrees.
35 degrees. That's it, 35 degrees. So it's the same shape. So let's now just bring them all together. Angle ADB. Alright, how do we do this?
ABD. Well, C and B are the same.
Yep.
So B is 60 degrees. That line is 180 degrees. So A is 90. 90 at 65.
62, I believe.
100. Oh, that's 62. That is 152 degrees. So then you have to do 180 minus 152, which is 28 degrees.
It's 28 degrees. 28, well done. Let's see, this one, MST. MST.
MST. So are P and S the same?
Yep.
So P is 48 degrees, and 40 times 2 is 96.
Right. But we don't have this little bit in here.
Oh. So how?
So I'm just thinking, I don't know quite the easiest way, but maybe if we join that up. So that must be 48 as well.
Yeah.
And so any idea about this one?
Is a 84 degrees.
So that's 84 degrees. And so how can you use that to get something else?
How can you use so 184
so M is at the center. O is at the O is at the center. M is at the circumference.
M is 42.
So M is 42. So how can we use that?
42 take away 180.
Yep.
Which is 138. And then 138 divided by 2 is 69.
Okay.
You have to do 69 minus 48.
Mm-hmm.
And it is 21 degrees.
So that there is 21. Hang on, we wanted MST. So we want that. I thought it would help knowing that that's 21, but we don't know this little bit down here. Or is there some way to get that? Let me check. Maybe, is this in the right place? 69. So we saw 69 here. Why is that though? You get 42. Tangent meets a radius. Ah, yes. A tangent meets a radius. So this OS is a radius. And RT is a tangent. And so it's 90 degrees between them. And so it's 90. So it's 90 minus 21. And so it's 69.
90.
Yeah, I think that's that one. Let's see this one. Alternate segment. So these two are equal. If you have a tangent on the outside and then this opposite angle on the inside, those are equal. Right, what's it called for this one? Wait. B to C to D. No, I need to move that back. Bring that back. Maybe not. I'm sure I always do that. Alright, let's try this.
Angle mark X. So is the other angle next to X 56 degrees as well?
I don't think so. There is another angle that's 56.
Is that B?
Yeah, that's alternate segment theorem. So that one's 56. And so, any idea about
75 at 56, which
yeah.
is 131.
Mm-hmm.
And to take that away from that, take it away from 180, and that is 48 degrees.
No.
49 degrees.
Yeah, 139, 149. Great. Okay, let's see if that. Then we have lots of stuff. Applying them. Work out the size of each angle. So I think this is a mix of the questions, is it? That one's okay. These look okay. Maybe it's just a mix. Okay. So what is question A?
Question A. AD is tangent to the circle. Work out so that each angle must develop. Okay. So A.
It's alternate segment theorem.
46 degrees.
It's alternate to 46, and so that's 46. So you can see how this is on the outside. Yeah.
Oh.
So, that's what I was saying. So how about angle B?
Angle B. So I only have to find angle B.
Yeah.
Okay. So 51 degrees and 35 degrees.
No. What angle is B alternate to?
35.
Yep. And question C, how about angle E?
7.
And angle G?
86.
Well done. Let's see, so these are, that's just like revision or whatever. Let me just take a look. Yeah, so it's revision for those ones. We did that one. Yeah, and so what do you give yourself for that stuff?
Say about half again.
That's all right. Well, this is the end of circle theorems anyway. Any topic in particular you want to do next time?
No.
Okay, I can pick some. Any questions for me in general?
I do not have any.
All right. Well, well done, Carlos. You did great. I look forward to chatting again next week.
BT.
Cheers. Have a good week. Goodbye.
Bye.